Welcome everybody to Solo Dev. So for the past couple weeks, I started and been working on a sample called Paragon Gas. It's really just a sample of how to build an open world and using gas, state trees, gameplay tags, and things like that. You can find it at the link in the description of the video. I have it on GitHub. Feel free to clone it, add to it, make suggestions, things like that. It's kind of here for all of us to learn and build off of. So while creating this, I started working with state trees. And this is a C++ project, by the way. And in learning more about state trees and a lot of things that they do better now in 5.6, I wanted to create a series of videos that will kind of explain a lot of these things that you will find in the sample when it comes to the state trees. I'm assuming that you know what state trees are, because I'm not going to go over what they are and all these benefits and stuff like that. You can find plenty of that from other content creators. I wanted to kind of use this time in this series to get more into the nitty gritty and show how you build a lot of the components the state tree uses from C++. So we're going to open up the content drawer, and I currently have a state tree that I'm modeling this tutorial off of. So over the course of this tutorial series, we're going to create a state tree similar to this with custom evaluators, custom tasks and conditions, and things like that, and quite a few pitfalls that you will fall into with your state trees popping to the root and things like that. We're going to start by creating a new state tree. Now, this also assumes that you've added the state tree plugins. If you have not or don't know where they are, you go into plugins, type in state tree, and you want state tree and gameplay state tree. And of course, it's going to ask you to restart your editor. So you go into the content drawer, you find where you want to save your state tree. So we right click, artificial intelligence, and then select state tree. So it gives you two different schemas to pick from. The first schema, I would say you would use this for something that like a door, maybe a stoplight changing, a security gate. For NPCs and enemies, I would suggest StateTree AI Component, as it allows you to connect your AI component to this. I have in the sample created a custom schema so that you will know what it looks like and how to create a custom schema. We won't use that in this tutorial series, but maybe in a later video we'll go over it so you can understand it. But it is possible to create your own schema. And there's an example of it in the GitHub repository. So we're going to pick StateTree AI Component, and we're going to call this STT tutorial. So let's open that up. Now what you're going to see here on the left, since we've chosen the AI component schema, you have the ability to set the AIController class as well as the actor class. The other StateTree component schema has just the actor class. We have a custom enemy AI controller, so we're going to select that. And then all of our enemies in the example have the same base class, enemy character. Here we go. So as you see, our contexts have changed from the actor to our enemy actor class, base class, and our AI controller to our enemy AI controller. Now, I'm not going to go over parameters in detail. They're simply parameters that are exposed to the state tree as a whole. Evaluators we will go over in part 2 of this series, as evaluators are critical to a performance state tree. Global tasks, similar to actually evaluators, as they span the lifetime of the state tree, but tasks are things that the state tree is doing. So you want to be careful with global tasks, as they are constantly running on the tick, performing actions. And then we have our color themes here. And so let's add a couple here and get this ready for what we're going to do. So combat, patrol, and then we're going to need one for group. I'm going to apologize ahead of time for the colors. I am colorblind, so I need colors that I know that I can see. Hopefully, the patrol. Oh, it's the wrong color. Hopefully that doesn't affect anyone too much. I need a darker green there, and then we'll make that red. Okay, great. Now let's pop into the code. So here's our custom AI controller header. And I have two events here that we're going to use for our 5 events that you're going to see here in a second. And this is for the stimulus event and the stimulus forgot event. Standard, begin play, on possess, unpossess. Our StateTree component is actually private, so I have a getter here. So here are some helper functions allow you to tell the perception to forget a specific actor or to forget an array of actors. There's a few gets here for the senses, so you can get all actors that cause damage. You can get all the actors that have caused a hearing senses. Sorry, I can't speak today. And all the actors that have been seen. Easy to use report damage event and report noise event. And then here's our 5 events that we have listed here that are using the signatures above for the delegates. On damage, on sight forgotten, on hearing, and on hearing forgotten. What's the important thing here are the sense configurations. So we're right now using sight, hearing, damage, and prediction. And in the constructor, we set these up. So here we're setting up the sight sense. Then we configure it to the perception component. We're setting the sight as dominant. We're setting up hearing config. We're setting up the damage config. And then we set up our perception config. And then this is where we bind to the event. And that is pretty much what our custom AI controller does. So that is going to be it for this episode, guys. And I hope you learned something. Please like and subscribe. In part 2, we're going to talk about evaluators, why they're so critical to having an advanced state tree. Thanks, guys. Have a great one.